Okay, so we're talking about rewriting equations, and that just means rewriting them in a way that makes them a little bit easier to solve. So if you look at this first problem, and we're going to be reviewing a few things while we go over this, so I would highly recommend that you take some notes on it. Plus, these problems are taken right out of your work for today, so it will definitely help. All right, so this first problem, I noticed that I have a common factor here, something that goes into all of those, that if I divided everything by it, I'm not changing the truth of that statement. So just a little side note. If I know that 2 plus 5 equals 7, it's just the same true if I multiply all of these by 10. 20 plus 50 equals 70. Or let's say I multiplied everything in there by, 3. 6 plus 15 equals 21. It's true. So it's okay. It's perfectly acceptable to multiply as long as you multiply everything by the same thing. You're not changing the truth of that statement at all. And so that's all we're going to do here is we're going to keep the truth the same, but we're going to change the way it looks. So I'm going to divide everything by 100 because 100 goes into all of these. And when I do that, notice that I have something that's much easier to look at. And then most of you would probably recognize that it has to, since there is an equal sign right now, I want to set it equal to 0. And so I just subtract 20 from both sides. So now I have x squared plus x minus 20 equals 0. Now I'm going to factor that. If you need help with factoring, just see my video on factoring, or I also have a help link in Moodle on factoring, but I'm going to factor it quickly. I know that I need a product of negative 20 and a sum of 1. And I know they both start with x. And so I'm going to use plus 5 and minus 4 because 5 times 4 is 20. And when I do outer, I have negative 4x, inner is positive 5x, so I'm going to get that sum of 1, which is what I need. And then just set each factor equal to 0. And again, if you need help with this, you should either come to the D-Day resource, go to After School Math Club, or come and see me. But I'm not going to talk too much about factoring today, mostly just talking about rewriting equations to make them easier to solve. So a lot of you don't like fractions, so in this case, I noticed that I could just multiply everything by 5. And when I do that, the denominator cancels in both of those fractions. So I end up with 2x plus 3 equals 5. Much easier problem to solve. You could solve that probably when you were in 8th grade. And so 2x equals 2 and x equals 1. Now, the kind that you probably couldn't solve too easily is something like this. So I see that I have a factor of x, a factor of x minus 1, and another factor of x. So I'm asking myself, what could I multiply? What same number could I multiply all three of those by to get rid of the fraction? I would need an x because x divided by x gives me 1. They would cancel out. But over here, I notice in this one it doesn't cancel because x and x minus 1 don't cancel. Just think about that, like pretend or think about x equaling a number like 4. 4 over 4 minus 1 doesn't cancel. So what we need to do is we need to include all of those factors. So I'm going to have to multiply everything by x times x minus 1. So now the x over x is 1, the x minus 1 over x minus 1 is 1, and the x over x is 1. So now what I have left right here is x minus 1 times x minus 3. Okay, remember that this is an implied grouping because they're together. Plus, And over here, what I have left is just 2 times x equals, and what I have over here is 5 minus x times x minus 1. And I got rid of all the denominators. So it's still complicated, but not as complicated. And now I can go ahead and use FOIL, x squared, and then I have minus 3x minus 1x, so that's minus 4x plus 3 plus 2x equals, and over here I have 5x minus 5 minus x squared plus x, because negative x times negative 1 is positive x. Okay, now I'm going to work individual sides of that equals sign and combine like terms. I see I have a negative 4x and a positive 2x over here, so that's going to be x squared minus 2x plus 3. And let's see, over here I guess I could combine a 5x plus 1x, which is 6x minus 5 minus x squared. Okay, now to solve this, I want to set it equal to 0. So I would add x squared, add 5, and subtract 6x from both sides. I'm going to line up like terms. So that was adding x squared, adding 5, and subtracting 6x from both sides. So now I have 2x squared. Do that in blue. Minus 8x plus 8 equals 0. Is that equal to 0? Now you could factor it or use quadratic formula at this point. A is 2, B is negative 8, C is positive 8. But what I'm noticing is that these 4 things all have a common factor of 2. So I could take all of these terms and divide by 2 without changing the truth of the statement. So now I have x squared minus 4x plus 4 equals 0. Now you can either use your quadratic formula if you want, or you could recognize that you have to have a product of 4 and a sum of negative 4. So I think negative 2 times negative 2 would work. But just in case you're not sure about that, you can always do the FOIL in your head to make sure it equals that. So x times x is x squared, that worked. Negative 2x and negative 2x is negative 4x, so that worked. Negative 2 times negative 2 is positive 4, so yes, that does equal the same thing, and then you can solve it. Now the key here isn't necessarily to solve. The key came in right here where I divided by 2 to make it easier for myself, and up here where I multiplied through times x minus 1, just to make that problem look easier. So hopefully you got that in your notes and you know the 2 keys of that. It's not solving, we've been doing that for a long time. What's different now is we're rewriting them, and that's the key for today. So now you can go to the next video.